everyone to HydroGraph's investor webinar. I would like to start this off by saying I'm sure many of you have seen the PR that we have issued this morning. We intended to raise 1.6 million and are pleased to report that we have raised 3.6 million. Thank you to everyone that participated, notably Power One Capital Markets and Haywood Securities, and of course, all new shareholders. So here, Ranjith and I have a presentation on our current and future aims. And with that, we'll get started. And of course, I am President and Interim CEO of HydroGraph Clean Power, and here with me is Ranjith, our Chief Science Officer. We'll start by sharing a company overview, followed by the market, our strategy and partnerships. We'll cover application development, as well as various technical case studies, and then we'll end with an outlook. So what does HydroGraph do? We are involved in nanotechnology. And really, if you view the ages of man, ages have been defined by the materials used, whether we're looking at the Stone Age, the Bronze Age, all the way to silicon. We are now entering the age, what you could call nanotechnology, of which will be dominated by graphene. And why? Because graphene is made of pure carbon atoms, carbon being the bulk of our natural world. It is extremely versatile. It has fantastic conductivity. It is the strongest material known to man. And really, this material is going to help usher in an age of nanotechnology. And this is going to touch virtually every known industry. What makes HydroGraph unique is that we own the patents for our proprietary explosion synthesis process, which yields the highest purity, most powerful graphene in the industry. If you look to your right, you can see a real image of our unit. This is roughly 2 meters by 2 meters. We pump in acetylene and oxygen. We ignite this with a spark from an electrode, and we are able to yield high purity graphene. We believe part of this is due to the temperature that we can achieve, which effectively rips apart the acetylene molecules and then perfectly recrystallizes into what we believe the highest performing graphene in the market. We are well within the commercialization process. We're excited to share later in the presentation our application development data that we have used in 20 different applications and have significant customer interest in. Our current production capacity is 10 tons per year, and that's per unit. These units can be built in a matter of 2 to 3 months. We can build multiple units simultaneously, and this is a very low capital intensive process. We are now fully funded. As mentioned, we have raised 3.6 million, and 55% of that is existing shareholders. For some highlights, we were founded in 2017. We do have 16 employees, 3 patents granted, 8 pending, many of which are very new, and now 11 and counting graphene products. And just to touch on the potential revenue that we can achieve with these units, as mentioned, CapEx is very low, roughly 10 million to 12 million of CapEx to generate 100 million in sales. And we'll dive into this a little bit later as well. So this is slightly dated. This is from 2017, but I think much of this still rings very true today, and anyone that's involved in the graphene industry can easily confirm this. So this was from journal Advanced Materials. They studied all of the graphene in the market. We did not participate in this study. And overwhelmingly, they found that there is almost no high quality graphene in the market as defined by the ISO. No company produces over 50% graphene content, with a majority producing less than 10%. These are really shocking figures, and really what this points to is that most companies are producing fine graphite, not graphene. And of course, most companies are using mechanical or chemical exfoliation with natural graphite to produce graphene, which of course takes a lot of energy to get down to that 1 atomic layer or very few atomic layers. Other companies also start with methane or other carbon-rich sources. But again, any other method that is endothermic, energy is put into the system, as opposed to HydroGraph's exothermic, where we, are giving off energy. We have a very different production process, and because of that, we have a very pristine material. So we make identical batches because we're synthetic. Every time we turn on the reactor, it is exactly the same thing. We produce 99.8% pure carbon content graphene, and this has been verified by numerous labs and verified by the Graphene Council. To go further into this, we produce pristine graphene with the smallest environmental footprint. Our production process is unique. Our energy demand is unique, and our end material is extremely unique. If you look at the chart to your right, you can see that our detonation synthesis has by far the lowest energy demand. When you're going to look at competitor processes, you'll look at chemical exfoliation and microwave plasma as two of the dominant forms. Not only is our production process a strong ESG play, but also using the end material is very good for the environment. We can so greatly improve the strength of materials that you can then reduce the amount of material, the legacy material that you're using on average by as much as you're increasing the strength, which for us is often double-digit performance improvements. So to give some examples, we can increase the ultimate strength of PET, which is a plastic, 22%. So you could use 22% less PET, which is a carbon-intensive product, 23% for low-density polyethylene, and 22% for epoxies. This would ring true for concrete. This can extend the life of lubricants, and many more examples. And so graphene can really be used everywhere. And just to touch on some of the traits, and we'll go into this more when we get to Ranjith's sections, but it's 200 times stronger than steel. It is flexible. It has fantastic thermal conductivity applications. It is impermeable in different applications, great optical properties. We can use graphene, even our graphene, for electronic applications. Normally, you're going to use CVD or monolayer applications for the more high-tech areas here. And then we see fantastic electrical conductivity at 1,000 times the current capacity of copper. And just for a timeline on the company, this patent was discovered in 2014. The patent was issued in 2016, all thanks to Dr. Chris Sorensen at Kansas State University, who was looking at aerosol gels detonated acetylene and oxygen, and then found that he had produced very, very high purity graphene. And of course, what we're most proud of is the consistency in that production method. So really, we went public on the CSE in December 2021. And since then, we've been very focused on commercializing this technology. In the beginning of this year, in 2024, we focused more exclusively on application development. And we do hope that with that success, we will have contracted revenue within I would say by the end of 2024 and looking to 2025. To touch on the team, so I was actually the first employee. I have been with the company since the beginning of 2020. My background is with various tech startups, anywhere from machine learning to blockchain. We have Bob Woke, who's an extremely experienced CFO, both within startups and large companies. Ranjith, who's presenting with me here today, has 30 years of experience at 3M, where he specialized in graphene-like materials. Of course, Dr. Chris Sorensen had invented the process. Stephen Corkill built all of the Hyperion units that we have to date. And Stefan Bossman is our lead chemist, and he has numerous patents associated with his name that we have licensed. And to touch on our strategy at high level is quite simple. We sell graphene. We do not sell or license the units. We believe that we produce the highest quality graphene at industrial scale in identical batches. This might not sound like a strong statement, but if you look into the industry, this is actually quite unique. How we focus on building the company is with a centralized production model. We believe that we can have better margins and better security and control of our IP if we have a centralized facility. And that is because our feedstock is acetylene. With gas, most of the cost with gas, as gas is not extremely expensive, is in compressing, storing, and transporting the gas. So with that in mind, we believe we can lower costs by locating next to an acetylene supply. We will likely duplicate this worldwide. We can have a North American hub, a European hub, an Asian hub, and so on. So we're not shipping too far to customers. And as we grow, as many graphene companies are including, we will include formulation and master batching, which is critical to thermoplastic industries and will really help to expedite commercialization. So I won't go over all of this. This is quite a lot of words, but what I want to touch on is that graphene is extremely versatile and can improve a huge variety of different markets. And if you look at these market sizes, these are massive. And of course, the addressable market of these that we can achieve is a lot smaller. But because our graphene is so high performing and so powerful, we have had fantastic customer reception when we do look at these target markets. We have great data with lubricants, and Ranjith is going to dive into some of the case studies, so I won't cover everything. fantastic data within composites. I would say composites and coatings are going to be the fastest to get to market with. Anything you're going to look at that's a load-bearing material or a structural material like cement or concrete has different regulations associated. So this would be one of the application areas we would look for partners or really other means to expedite that. And then we have also fantastic data within energy storage. And so to tie this together, we are focused on composites, coatings, and batteries, and we do this work through the GEIC, that is the Graphene Engineering Innovation Center in Manchester. This is fantastic for us because we have access to customers, we have all of the expertise there, we have industrial prototyping machine, different characterization devices, and we're not ignoring the other markets, of which concrete and lubricants would be the largest. Many others you could put in there, biosensors and more. We are still looking at this, but we would pursue partnerships or look at targeted R&D to unlock these markets, but we need to be focused, and we have decided to focus our funds and our attention on the ones that are fastest to market. So I'll briefly pause here and I will show a video on the GEIC.
Graphene Engineering Innovation Centre, the GEIC, has been specifically designed to take the science from across the University of Manchester, from the lab, into products and applications.
The GEIC works alongside industry partners, and the idea is to accelerate and commercialise the use of graphene in lots of different applications and in different materials.
What our partners love is the fact that we can produce prototypes rapidly, analyze and test these, sometimes even within days. So we are really aligned to the speed that industry like to innovate. So what actually GEIC does is it helps in de-risking the industry adaptation and validation of graphene and 2D materials for their mainstream products.
Gerdau is one of the largest South American long steel producers. We've been very lucky to develop almost 5 projects and also develop a patent, which is great for intellectual property, and a product of our own with graphene enhanced product within a year, which is pretty fantastic for us.
We want to come up with a design, rapidly produce a prototype, see if that works. If it fails, fail fast and learn, or to make it work and then to iterate that rapidly into various products or applications. We have applications around composites, so that's everything from adding graphene into rubber, into plastics, into carbon fibre, into metal matrices. We have an energy lab where we can make new forms of batteries or supercapacitors for energy storage. We also have a coatings and membranes line.
One of our big topics that we work on is coatings for the corrosion market. These coatings are in automotive sectors, aerospace, marine, or construction, for example.
We also have the ability to make different formulations of inks or resins, and we can then make those into wearable products or sensors or RFID devices. Core to all of that, though, is also the measurement and characterization capability, where we can do that rapid test and measurement to make sure we really understand what's taking place when we add graphene to that product or application.
We've traveled all over the world when we're analyzing advanced materials, and Manchester is by far one of the most advanced places when it comes to graphene application development. We have the technicians, the application managers, and the staff. We work really close together, fast communication, easy access to. So I would say I'm very lucky of being part of working for my company, but also being part of the GEIC family.
Graphene is moving incredibly quickly. Already, only 16 years young, we're seeing the first products and applications hitting the marketplace. And it's now not just a few niche products, we're seeing some large manufacturers using graphene in their products or their applications to create real competitive advantage and benefit. So those who are thinking around working on graphene but have been put off, what I'd say is a number of companies are starting to see real benefits, real improvements. I'd encourage them to engage, and we've developed a business model that makes it quite easy for companies to engage around a small feasibility project that will potentially lead into a bigger project and a number of projects going forward. So my message to people is to engage, to talk to the team, and to see how we might support you in your products and applications where graphene can make a real productivity and performance advantage to your business.
We are very happy with this model. We have performed very well since we have joined. They are under mandate to use the best performing graphene for every application. And so James Baker, the CEO of The Geek, he does serve on the HydroGraph Advisory Board. We're very happy to have him as a resource and to have his support. And so here, let's start with round 2 for the video. And this is showing our units.
Beginning with readily available industry gases and a combination of patented and trade secret technology called the Hyperion system. HydroGraph simply produces the highest quality graphene in the market. HydroGraph's fractal graphene is certified by the Graphene Council as few layer, that's 2 to 10 layer, non-functionalized turbostratic graphene in a size of 20 to 50 nanometers. It has the highest consistency, and it sets the industry bar in purity at 99.8% pure carbon in the form of graphene.
Okay, and so you can see with this unit that we use readily available feedstocks. Acetylene is available in any industrial zone and is available globally. And then our patented Hyperion system does produce the highest quality graphene in the market. So with that, I will pass this on to Ranjith. He's going to cover more on graphene. This graphic is taken from the Graphene Council. I highly recommend anyone viewing this to go to their website, as they have, a lot of material and they're a fantastic resource for looking at advanced materials.
Thank you, Kjirstin. You can hear me, right?
Mm-hmm.
Yeah, so I think for anyone who doesn't know about graphene, it's the thinnest material in the universe in solid form. And because of the carbon-carbon bonds, it's made out of carbon atoms, just one atom thick. Because of the carbon atom bonds, it's the strongest material known to us. And it has all these fantastic superlative properties, extreme properties compared to any other material. That's why it's really interesting. Well, that's one of the reasons. The other reason is carbon, which is a very abundant material, accessible to all of us, right? So if you go to the next slide. So HydroGraph, as Kjirstin mentioned, has a fantastic technology to make this in commercial quantities very reproducibly. And we have that technology has been protected through a portfolio of patents. I think if you go to the next slide, please. Our major patent is Chris Sorensen's fractal graphene patent, but there's a growing number of IP being developed right now. I don't want to get into all the details, but we are looking after the technology as well. So the question comes, so we have such a nice technology and we have a nice team. What do we do with this technology? What kind of problems can we solve with this that can help the world really? So what we have selected is to showcase some of the case studies in different market segments and look at what the performance of our material is. So we have selected 4 examples, and first one is going to be on composites. So if you advance the slide, yeah. So thanks, Kjirstin. I think composites are very important to us because it's everywhere really, because plastics, especially polymer composites, has been with us for a long time and has helped the humanity in the modern world, right? Modern living. But it also comes with some certain problems, like the pollution and the responsibility for the greenhouse gases. So what we are trying to address is, as mentioned earlier, I think if you add a small amount of our graphene into these material systems, we can get better performance, whereby we will enhance the strength of the material, for example, or any other, most of the useful properties. Then you can use less of the original material. And I think that's not only true for just one kind of plastics, but for many type of plastics. So we are on to the next slide now. It's on the energy storage. I think where we have gained performance enhancement by small addition of the material. So if you look at lithium-ion batteries or lead-acid batteries or future technologies like lithium oxygen or lithium air battery, all of these have one thing in common, that's the electrode material, which is an active material mixed with some conducting particles to make it electrically conducting. Because without the electrical conductivity, when the current goes through the device, it just gets wasted to heat, turn into heat, and that's a loss mechanism. So we want to minimize that loss by improving the conductivity. And our graphene is a good electrical conductor. So by just putting a small amount into all these devices, we have shown with third-party commercial operators, when you benchmark against the standard incumbent, which is the carbon black as the conductive additive, we perform way better. If you take the lead acid battery, it's the legacy product, but still we can improve the dynamic charge acceptance rate by 47%, which is typically really unheard of, that kind of performance enhancement in the battery world, which means we can charge the battery very quickly. And if you look at the supercapacitors, by adding our material into the active material, we can increase by 4x the capacitance of the supercapacitor. So much more energy can be stored. And we are working with many commercial partners to bring this to market right now. If we move to the next slide, please. Yeah, so the very different market. This is the construction industry. We look at the cement and mortar industry. Very recently, we did a very extensive study with Arizona State University on the sustainability and engineering department. They found again, with just 400 parts per million of our graphene added to cement, increases the performance dramatically. So cement industry is one of the bigger contributors to the global greenhouse gases by about 8%. So to address this issue, a lot of people are trying to do the decarbonization, and one of the approaches to make the cement, the footprint less, carbon footprint to be lower, and we can do that by adding a little bit of our graphene. And I think this is more for the future, as Kjirstin mentioned earlier. We have to find partners for this one. If we go to the last one, the next slide, I think we talked about completely different market segment, which is in the biosensor area. I think this is another sort of a landmark case where we make a step change in the marketplace. And also, this is a very long-standing relationship with us and Hawkeye Bio, which is a biomedical company out of California. And they looked at making biosensors to detect lung cancer. Why lung cancer? That is because the lung cancer is the world's deadliest cancer. If you combine the next 3 cancers, the mortality rate is even higher for lung cancer. So 70% of the people diagnosed die. So this is a serious and problem which cannot be addressed with the existing technology. Right now, when we detect the lung cancer in the people, it's too late. Palliative care is the only solution. So what I think our lead chemist invented this technology, co-invented this technology with Hawkeye Bio. We take by actually the other very important part is Hawkeye Bio had tried a lot of other nanomaterials, multiple nanomaterials and different type of graphenes, and found ours works the best in this application. So what we do is we take our graphene particles and then put a fluorescent biomolecule onto the surface, and that reacts with very precursor enzymes produced by the tumor cells, in this case, lung cancer cell, and it gives a very nice signal that can be read using a very common fluorescent plate reader that's available in any biolab. And other thing is this is highly efficient. So very large clinical trials in 3 countries have already shown that 90% efficacy of detecting this cancer and at a very low cost. And since we can detect this at stage 1 level, is completely treatable. So now Hawkeye is shipping these kits to the clinics, and the hope is this is not only just for lung cancer. What their work has shown us is that this is good for 14 more other cancers like pancreatic cancer, very serious diseases. And going beyond that, so it's a platform technology for Hawkeye Bio, which works on our graphene, the fractal graphene as the base material. And then even, just beyond that, because of our aging population, there are a lot of demographically much more significant diseases. And the lab results show we can detect those very early as well. So I think this is as I said, it's a big step change in the medical biotechnology, because this will save millions of lives. So I think those 4 case studies show the breadth of the things we can do with our graphene in the commercial space. So I'll turn this to Kjirstin to show what are the next steps building up on these things. Thank you.
Thanks, Ranjith. And I would actually add to that Hawkeye Bio had tried what they claim is all the graphene in the market. I'm assuming that they've done some research and tried a subset because there's quite a lot, but they found that we were the only one that they could use due to our purity and our consistency, which is of course critical to anything that is going to have FDA approval. And this was now published in the journal Nature that I would encourage anyone listening to check out. And so this is, I think, the most exciting part of the presentation is our commercialization. I'm going to give 3 examples and I'll touch on a 4th, but we are speaking with a large automotive company. We cannot share everything as, of course, we are under NDA. We have performed 3 successful trials integrating graphene into various automobile components. We are working on a pilot industrial scale-up within 2024. This will be followed by a commercial scale-up and negotiations targeting 2025. We are expecting tonnage volumes. We will, of course, release more information as information is available. We are in discussions with 3 major PET producers. Again, this is a packaging plastic. Our initial results have been replicated by multiple parties, and initial results, I'm referring to the results that we generated at the Geek. We are now looking at a pilot scale-up slated for Q3 2024 and commercial scale-up when we achieve FDA approval. We are well within that process. We are first looking at an FDA approval letter, and the entire process will, of course, take a little bit longer. We do see potential in hundreds of tons of graphene. If fully commercialized, this would be in the thousands of tons. It is unclear to us how much these companies will want to commercialize what they have in terms of their volumes. And we're also speaking with a large energy storage company. We're working on a pilot industrial scale-up this year based on reproduced results. And we are already in process of negotiating a supply agreement with this company and then with distributors. And we are expecting tonnage volumes. As a 4th that I just want to touch on, we are working on a very large concrete project. This is, of course, with a partner, as I had indicated previously. I don't have an idea of a timeline yet, but so far initial results have gone very well, and we do expect the regulatory aspect to be expedited. And again, we will give more information as it becomes available. But just to go through the timeline, we start with the Geek. We generate our application data at the Geek. And to go back to that video, when we edit this later and post it online, we'll have that video included so everyone can look at really what those Geek capabilities are. We then collaborate with different customers through the Geek, and we use that data to take back to our own business development team, who will continue to reach out to additional customers. We engage in product development with the customer. We help them to integrate graphene into their products. And then when that's successful, or if it's successful, we move to industrial trial. We sign customer contracts, and then we, of course, scale up production. We are lucky that we are so scalable, as we can build new units in a matter of months, and again, very low capex, that we can put those conjoined. Most other companies, of course, need to put scale up production higher on that list just because of the relatively large build-outs that they look at. We estimate this whole timeline, just because there's quite a bit of testing that we're looking at, is within 1 to 2 years. It could be shorter. We find that with Geek activities, we can shorten that. And if it is completely customer-led, if we're looking at concrete or lubricants, it could be a little bit longer, and every application area is going to be a little bit different. We always try to do our best to keep it short and, of course, cost-effective to the company. To wrap everything up, why is HydroGraph a good investment? we feel very strongly that we have the highest performing graphene in the industry at industrial scale. In a way, you can compare us to CVD graphene because we're both synthetic, and the Raman signature, that's a way to characterize graphene, is identical. You can kind of think of us as explosion CVD, and we feel, most importantly, we have the data to back it up. We are really looking forward to sharing more data. We have fantastic results that we have not been able to share yet, and we do have fantastic customer reception. So I think that, 2024 and especially 2025, these are going to be very exciting years for the company. I think we've reached a very pivotal moment in our growth. We have consistent results. Unlike other graphene producers, we produce identical batches. Every single time we turn on the reactor, we get exactly the same graphene. Every time we scale it up, we have exactly the same graphene. This is one of the reasons why graphene has failed to commercialize, because when a customer orders, often they don't get the same graphene as on the data sheet. And more importantly, when they order a larger sample size, it's not the same graphene. Of course, not with us. HydroGraph, we don't have these issues. We've had excellent conversations, and customers have shared a lot more that this has been a struggle for them in the past. And we do think we can be a catalyst for the whole industry to start commercializing some of these applications we've mentioned. Going back to the ESG component, we have a very green footprint. We have the lowest energy in the industry, and we produce no waste. We have a byproduct of syngas that can be sold as it's a commodity gas. And going back to energy, this gives us absolute freedom with where we locate because we don't care about energy costs. Most companies are actually locating in territories where they can achieve lower energy, for example, Quebec. We don't really care. We can locate virtually anywhere there is abundant acetylene. So we are very, very scalable and very, very flexible. We have global reach, not only for the reasons that I just mentioned, but the reasons that graphene can improve virtually every material that you can think of. So really, the potential is unlimited. We have strong economics. We have excellent margins. We have a strong competitive advantage. We can produce what we believe for a very low cost, a very, very high performing material. To make that point even stronger, we often can use 1/10 or 1/5 the amount of our graphene as compared to competitors because we are so high performing. And then, of course, there's significant valuation upside. We have a low capex process. We have very large end markets, and some of these markets have rapid growth. We have differentiated products. We have 11 graphenes and counting. We're constantly innovating. We're constantly creating new materials. And all of this gives HydroGraph a huge amount of potential. So key catalysts, we are extending our application development capabilities. We believe we will close our first major multi-year contract. I am hoping for multiple major multi-year contracts, certainly within the next 12 months. And we will constantly be increasing our product line. We now have an updated cap structure as we have just closed this last round. Again, thank you so much to Power One Capital Markets and Haywood Securities for leading that. We now have 231 million shares outstanding, a significant amount of warrants outstanding that we do hope we'll see within the next year, and a market cap now of 43 million Canadian. So again, thank you everyone for attending. Please submit any questions that you have with the Q&A tab, and we look forward to hearing from all of you.
Wonderful. I think we do have some questions that we can answer here, Kjirstin.
Mm-hmm.
Yes, I'm just going and reading these. I see, how much money do you plan to raise in the future? So what we have just raised, the 3.6 million, will take us into 2025. As I mentioned, we have a pretty significant amount of warrants that are outstanding, priced at, most of them, I believe, at 18 cents and 20 cents. I think this is potentially all of the money we need. We may not need to have another round. If we would, we'd be at a very, very different valuation. So I do think we'd have support, but that certainly would not be anything we'd be looking at for a number of years. And, if we do need to build a large facility, I think we could look at debt financing or a number of other creative means of achieving the capital that we would need for that. So to wrap that up, we do believe this last round will be the last round. I see another question in third grader terms. Will HydroGraph graphene?
Want to take that?
Yeah, sure. A candidate from Microchips. We'll let Ranjith answer this one.
Yeah. So I think our graphene we make is in the powder form, so 20 to 50 nanometers in size. So for microchips application, people look for CVD type graphene monolayers or bilayers. So we won't be likely working in the microchip industry unless we make very thin coatings with our material and that performs. So that remains to be seen.
And I think another is addressed to Ranjith. What about Universal Matter, who also produces turbostratic graphene?
As Kjirstin said, we make the best graphene in the world. So we stand by that. The thing to realize is our raw materials, acetylene and oxygen, is highly controlled and very pure. So you input pure material and we get pure material out. Whereas most of the other players in the industry are using biofeeds, different feedstock, biosources or coal or something relatively impure to start with. So they will have a hard time getting the purity that you need in some of the high-end applications, which we don't. So I would say Universal Matter in the other category. Otherwise, they have to purify it. So again, addition of more cost.
I think to go back to some of our earlier points, we see a pretty large difference in the performance of our graphene versus other graphene. So not calling out any specific company. There are quite a lot of claims, I guess, still within the industry. And so I see a follow-up question: who's responsible for business development and partnering deals? I would say management to a large extent, and we did not show the full team. I think that is quite apparent. We have a team of 16 people. We do have a director of business development, Randall Zajac, and he has been focused on composites and coatings. Just to reinforce the geek strategy and messaging there, we do have a team of 3 PhD scientists, and they do a lot of work on application development at the Geek, where there is a huge influx and network of different customers. So I would say our activity at the Geek is, in a way, our secondary business development source, not only from our own people that we hire, but also with our relationships with the actual Geek staff. And I think it's quite obvious, but we're very happy at the Geek. Highly recommend anyone reaching out to get more information. If anyone listening is a company that wants to integrate graphene into their products, check them out. We're very happy that they've approached us so often to work with us in different projects. And I would say that it's increased the speed in which we can get to market and really cut off a lot of time there. And so major sources of acetylene, so we don't have our full facility. We do have numerous facilities selected to supply us with acetylene from the pipe. We are currently producing in Manhattan, Kansas. This is not adjacent to a major acetylene production plant. So we are using cylinders. It's just readily available commodity gases with the dominant suppliers in that region. But of course, as mentioned, we are working on those plans for the larger scale up, and we will share that as that information becomes available. And I don't see any more questions. If anyone has anything else they would like to ask, please do put something into the chat.
There's one question about the properties of graphene. And please check our website. We have a lot of data sheets. So they're very well documented.
Volume of syngas of a 10 machine.
I don't have that answer ready. So.
Right. We can follow up with a concrete number there. Where do we see the company in 5 years? I think this is my favorite question. We do believe that HydroGraph will be the dominant graphene company. I think we have everything it takes to get there. We have the best production method, in my opinion. We really have the best graphene. I think our progress this year alone really shows that. We're really looking forward to showing more data. I think our data is extremely strong, and as is the customer interest. So of course, there's a timeline associated to these scale-up plans, but good things are coming within 2024 and absolutely within 2025. So to imagine where we will be in 5 years, I think it's going to be great to see that. And for a follow-up question there, is there any risk of our process being stolen? That is something that we are constantly thinking about and constantly focused on. This is one of the reasons why I'm pushing for a centralized production facility where we have more oversight and more control of our IP. There's little any company can do from a a player within China from, doing what they would like. With that said, we will do everything that we can to maintain the security of our IP. We will fight things when we can. But I think the important thing for companies like us is just to innovate faster and grow faster than your competition. And I think that's really the best thing that we can do.
Someone is asking about the number of layers.
Sure, if you can take that
Yeah,
one.
so it's 7 plus or minus 2. That's the statistical answer, but it's way less than 10. So it's what we call a few layer graphene.
And I would say the distribution's towards the lower end of that.
Yeah, very
as
low
well.
end.
We can tweak it as well. And so how many units have we built? The very large one, we do have one. We are planning on building a second very soon, but in total we have 6 units. Some of them are small. We use these for research purposes, and then we have a couple mid-sized units. So we do have quite a few, and of course we're continuing to scale that up.
Yeah. And Kjirstin, another point to mention there is, I think we have gone through iterations of scale up from very small unit to medium size and large. So it has gone really well. So we don't see any issue even making a bigger unit, but we are thinking we are more trending toward duplicating the unit now we have, because that's very well known and under very well controlled system.
Right. Our engineers have done a fantastic job in that scale up. We do have quite large explosions currently, but all of the engineers are still alive. Do we need pure oxygen? Yes, and this is a commodity gas, so it is very easy to source. Graphene ink. We are looking at ink. It is not one of our dominant focuses now, but if there's interest, we will always, engage with a customer. And with our location at the Geek, we have more recently discovered a highly conductive graphene type. So I think these application areas become much more appealing now that we have discovered this, and this is a very recent discovery. So we'll continue to update the market as information is available. I think this is a good question. Can composites, coatings, and battery applications be commercialized without FDA approval? Overwhelmingly, yes. FDA approval is really something that is touching food or, within that ballpark. So if it's a packaging plastic like PET is mostly used for things that would be FDA approval compliant, whether it's water bottles or, a packaging film that goes over food, we would. But most applications, industrial applications, certainly batteries would not need that. EPA, the Environmental Protection Agency, is a separate matter. We are well within that approval process. We do expect to have that. We can certainly be selling anything that we'd need for research or scale up. What keeps us up at night? I think all in all, we've made fantastic progress. I think, just to reinforce what I've been saying, the past few months have been really fantastic. I think this might be a funny comment, but we have so much interest that I do think about the scale up, and this is a problem I'm going to be very happy to deal with, but we may be with, multiple customer contracts coming in at the same time, have a very, very quick scale up. And, with anything happening quickly, of course, the interest is fantastic, but it is a lot to put together at one time. So again, I'm happy to have this problem, but it is something that I'm thinking about, is how we're actually going to achieve this. No, we don't plan to market in China. We're completely open to selling our graphene in China, but we will not be producing in China. We'll certainly not be sharing anything relating to IP. Where there's a question, where is the first Hyperion hub going to be located, the US or the Middle East? This comes down to customer interest. So until we have a real contract in hand, and because we can scale quickly, we don't really need to make that selection now. With that said, we do have the plans for each region. It could be within the US, it could be within the UK, it could be within the Middle East. And going back to just the process with customers, we will have enough time just due to the time that goes between meetings and just general. These large companies are also slower to make decisions. So we will be able to select, and as I mentioned in my last answer, it could be that multiple will need to go up in relatively short order, and that is completely possible. How many NDAs do we have now? To be honest, I've lost count, but it's a lot. It is. Do you have an estimate, Ranjith?
More than 30 for sure, right? I mean, this is the number.
I would say much more than 30.
Yeah.
I would say closer to 50. I believe
50s.
we've signed a number recently. But again, I do want to say a word about this. I would say that investors shouldn't really care about NDAs. I believe in slightly different messaging here. We could have 100 NDAs, but if they're not going to lead anywhere, that doesn't really matter. What matters is what are we doing that is achievable in the near term? And we have achievable gains in the near term with the companies that I had mentioned. And I know you guys don't have the company names yet, but I hope you will soon. The large automotive company, the lead acid battery opportunity, the 3 PET companies, and the large concrete opportunity. These are what we should be focused on. These are real, these are attainable. And these 4, I would say, we're going to be releasing more information soon. So let's move away from the focus on NDAs.
Mhm.
Do you see any additional ones, Ranjith? I think we've answered everything that I'm
Yeah.
seeing. Our next webinar news release, we'll be planning one shortly. We plan to have much stronger investor relations. We will be uploading additional videos. We will have more regular webinars. And as always, I would encourage anyone listening to reach out to myself, to Ranjith, if you have questions or comments about the company. We're more than happy to schedule a call. When do we expect to be cash flow positive? I think this is a good question. It's difficult to predict exactly. As I've shared, we have a lot of interest. I think that we'll be in the contract negotiation phase with these companies within the end of 2024, if not the beginning of 2025. But really, I think investors should see 2024 as we're proving what we have is real. We're proving this interest, and we're creating that path to seeing revenue. But I don't think significant revenue will come in until 2025. And I would say probably at the later end, the beginning of 2025 is probably finalizing those contract negotiations, completing our scale up, but real revenue, cash in the bank for us is going to be end of 2025 to 2026. And I think, we should have a very different valuation well before we have real revenue. Long lead, I have a question on, are there long lead times on making your machines? No, we can produce machines in a matter of months, 2 to 3 months. There could be some supply chain hiccups, as with anything industrial, but nothing that we're foreseeing. And we will be ordering everything well in advance as soon as we have line of sight. So these are not things that we see as issues. And we do use mostly off-the-shelf components. I do want to reinforce that. We do produce everything in-house. We have lots of modifications, lots of trade secrets, but we can easily swap out vendors. And we think this is, again, one of our defining characteristics for our scalability. I also see another question on, do we see HydroGraph as a takeover target? Certainly. There's been interest in the company. I think we could be a target to be acquired. And I think that, there hasn't been something tangible on the table, though there has been a lot of interest, and we would continue to update if anything does move forward.
Yeah.
Maybe Ranjith, you want to take this? Does adding your product to construction products such as aluminum reduce? I think.
Yeah, so there are a lot of, not a lot, some academic literature showing you can enhance metals with graphene as well. That's something we haven't tried, but I think with Geek we will try pretty soon. So we'll keep you updated. But there's a lot of hope beyond this plastics and other material we are showing.
And mostly with metals, we're going to be doing coatings. So we can certainly improve, again, virtually every material.
But going to metallurgy itself is really, really interesting. I think that's sort of is being recognized right now. So being a true nano material, which is our graphene, makes a huge difference. Not all graphene will work the same way. We will have a huge advantage there.
Agreed. And so we have a question on, is it related to CVD or is it freestanding? I think just to explain the different methods, chemical vapor deposition is depositing methane and then you grow a layer of graphene on a copper substrate. We're very different. We pump in, again, it is a hydrocarbon, acetylene and oxygen, and then we detonate that, and then we get pure pristine graphene. So The Raman signature, which is how you characterize graphene, looks very similar. So we could kind of describe this as explosion CVD, but we're standalone. We're not related in terms of patents to that. We have our own patents, and we have enough significant differences to that.
And someone is asking, Mohammed is asking, can you provide samples for battery research? Yeah, please get in touch with us, send an email. We can definitely give
Can
you
I
some.
elaborate on the application use for the auto manufacturer? Unfortunately not. I have already shared some information and I'm under NDA, but as soon as I'm able, I will share more. And in-house manufacturing capacity, we are in process of scaling that up. So we will update the market as soon as we do have that information, but we feel we can produce enough for all of the application areas we're looking at, even as customers start to order hundreds of kilos or even tonnage amounts. So our team, can easily build new units. Once we're building 10 units, 20 units at a time, we'll certainly have a larger team and a larger location to do so. Okay, and I'm not seeing any questions come in. If anyone has anything additionally they'd like to ask, please put that into the chat. And if not, we do thank all of you for tuning in and for your support in HydroGraph.
Thank you so much.